can we use the 0 of 2 to get 0? Does this work? So you evaluate for p of 2 by putting in 2 for x, and that's 32 minus 32, which is 0. Since we got 0, that proves to us that yes, x equals 2 is a solution. X equals 2 is a solution because when you evaluate it at 2, you get 0. We found the 0. So is it a factor? Yes, that's the first part of this answer. It is a factor. So if you want to use this method to find if it's a factor, all you have to do is you have to solve the factor, find its 0. Our factor was x minus 2. We solved it, found x was equal to 2. Evaluate the polynomial at that x value. If the polynomial equals 0, then it is a factor. That saves a whole lot of time from doing long division. Mackenzie?
Would you have to use long division to find the other factor, though?
Yes, exactly. Very good, because that's the next part of the question. If it is a factor, write p of x as a factor of 2 factors. So we're going to do exactly what Mackenzie said. We have to take our x squared minus 32 and divide it by x minus 2. Now, remember those placeholders we were talking about yesterday? We have to have a whole bunch of them here because this is a quintic function, but it's only got 2 values, a quintic value and a linear value. So when we write this x to the 5th minus 32, we actually have to have x to the 5th plus 0x to the 4th plus 0x to the 3rd, 0x squared, 0x, and then minus 32. Okay, so lots of placeholders here. And then x times what is x to the 5th? 1x to the 4th. Be careful here. We're subtracting. So x to the 5th minus x to the 5th is 0. 0x to the 4th minus negative 2x to the 4th, that becomes positive 2x to the 4th. And then bring down your x to the third value. And after a very, very long division problem, we finally end up with our answer, x to the 4th plus 2x cubed plus 4x squared plus 8x plus 16. With a remainder of 0, because we already knew that we were dividing by a factor of this polynomial. So if you did not get a remainder of 0, then you should kind of have a warning sign go off and say, wait a minute, I divided by its factor, I should get another factor. And the problem said, write this polynomial as the product of its factors, I believe is how it was worded. Yes, as the product of its factors. So all you would have to do there is you would have to take your quotient and your factor that you already knew, and you can say P of x, the polynomial, equals its original factor, the x minus 2 that we used, times the quotient that we just found. X to the fourth plus 2x cubed plus 4x squared plus 8x plus 16. So in your homework, there's going to be a section that says, are these factors of the polynomial? All you have to do is you have to find the x value, plug it in, and see if it equals 0. That's going to tell you whether it's a factor or not. In your homework, it doesn't say to write it as the product of the two factors. So in the homework section there, you're not even going to have to do the whole division. All you're going to do is find out if it's a factor or not, and then move on from there. Now, it was easy to use the 0 method for a factor such as x minus 2, but you are going to have other factors that you can't solve so easily. For example, in the got it number 2 question, it's saying is x to the fourth minus 1 a factor? It's going to be easier just to do your long division there and find out, okay, is this a factor? Do I have a remainder? If I have a remainder of 0, then I know it's a factor. Now again, why we are just doing division right off the bat here is because x to the fourth minus 1 cannot be solved as easily as x minus 2 equals 0. So we're going to do our long division. Don't forget your placeholders, like I almost just did. So no matter what your highest degree is, you're always going to count down the degrees from your highest one until you get to your constant number. And then just go ahead and do your division. Yes, Andy.
Don't you need to put the placeholders in the divisor that you're using? On the left. Like where it's.
Yeah, you could do it that way. Yeah, you can. The way I would do it would be without them, so you wouldn't have to write as much. But for you guys, it would probably be easier. So yeah, let's do it that way instead. Let's put your placeholders here, because it will line it up more easily for you guys and be easier to understand. So we'll do it that way. So we've got x to the fourth plus, oops, make that black, plus 0x to the third plus 0x squared plus 0x minus 1. It's one heck of a division problem, if I do say so myself. Mackenzie? You don't have to, but I think it's going to be easier since you guys are just learning the long division. I do think it'll be easier to do it this way. Okay, So now you can go through. X to the 4th just needs to be multiplied by x here. So now we're going to multiply all 5 terms on the outside left side by this x. It's going to be minus 0 minus 5. X to the 5th, 0x to the 4th, 0x to the 3rd, 0x squared minus x minus minus. Okay, there we go. And then you have to go again, and you have to say, okay, what can I multiply now to get 5x to the 4th? Because this is your value here. These ones right here. Negative x minus a negative x. Negative and negative is going to be positive, so that's just going to be a 0. So we're going to then add 5 here. And we get a big fat remainder of just 0. And since we have a remainder of 0, what does that tell us about our initial divisor, this x to the 4th minus 1? Steve?
It's a factor.
Exactly. So now we have our 2 factors. And since it is a factor, it says, is it yes? We'll answer it yes or no. Yes, it's a factor. Write it as the product. When you write it as the product, you don't need to put all the placeholders. You can just put x to the 4th minus 1, and then your quotient, x plus 5. Now, if you would not put all of your placeholders in your divisor like that, you could still do it, okay? If you don't want to put all of your placeholders there. I think since you guys are just learning it, it's going to be easier if you have that visual to see them lined up. But if you didn't put your placeholders there, all you would do is whenever you were multiplying this x, whenever you multiplied that through, you would realize this would be x to the 5th. And then your only other value there would be minus x. So you would just have to know that that x to the 5th and that negative x have to line up under the quintic term and under the linear term. So you could technically do it without the placeholders if in your mind you feel comfortable lining them up in this subtraction part of the problem without having those placeholders there. But that's just completely up to you. It's kind of like a shortcut if you don't want to go through that whole list of things. But like I said, I think for now, for you guys learning it, the placeholders are going to help you from making a mistake. Okay? So if you're asked if it is a factor, if you can, use the remainder, or use the 0 method. solve it, put it back in, see if you get 0. Then you know if it's a factor. If it's not easily solved, then go ahead and just do the division. And now we're going to do something called synthetic division. You guys said you've never done this before? No? Never? It's not really hard, it's just kind of different. I don't think I ever learned synthetic division in high school. I don't think I did. We talked about it in college. It's not something that's commonly used, but it is mentioned, and it is kind of a neat shortcut because it doesn't take very long to do the division. So we'll try that for today. And it has it kind of step-by-step written out here for you. So if you read the directions, it's telling you to use synthetic division. We're dividing this cubic by x plus 2. What's the quotient and the remainder? So you're still dividing, you're still getting a quotient and remainder just like you would with long division. This is just a shortcut. So step 1, it says reverse the sign of positive 2, write the coefficients of the polynomial. Okay, so you take your divisor, you take this x plus 2, reverse the sign of it. So that's why we use negative 2. If that was x plus 5, then we'd use negative 5. If it was x minus 7, then we'd use 7. Okay, you reverse the sign of your divisor. It says, then write the coefficients of the polynomial. In synthetic division, they kind of use that sideways, rotated, division bar looking thing. And that's really just to separate your numbers. And then we just read our coefficients. So coefficient on x cubed is 1. Coefficient on x squared is negative 14. Coefficient on x. And then just your c value. And then the next step is always to bring down your first term. So this is kind of what it looks like. We have our top row of the divisor, and then all of the coefficients. And it says bring down your first term. So you bring down the coefficient like so. Did you guys figure this out from the steps?
Yeah.
Very cool. Okay, now what you need to do is you need to multiply that coefficient by the divisor, add it to the next coefficient. So this is what it looks like. Negative 2, 1, negative 14, 51, negative 54. We already brought down our first one. So now what step 3 is saying is take this coefficient you have, multiply it by the divisor. So 1 times negative 2 is negative 2. And then you add that column. Negative 14 plus negative 2 is negative 16. And then step 4, I'm not going to rewrite it, but it says continue multiplying and adding through the last coefficient. So what we do is we just repeat that process. Now we're going to take the negative 16, multiply it by the divisor, negative 2, list it, and then add. And then you take this number, multiply it by the coefficient, and then just add them. I find it strange that the step-by-step questions don't tell you how to write the answer. I mean, we're done here, but they don't tell you how to write the answer. They just tell you how to do it that way. But that's all right. We'll add step 5 on our own to tell you how to write the answer. Now, this looks kind of crazy, but really, we've got our answer to our division problem. We have our quotient right here in front of us. The last number you came up with, this number right here, is your remainder. And then for everything else, you just add an x term. So we start with our constant, and then it's our linear term, and then it's our quadratic term, and then as many terms as we need to go, you just work your way up. So when you rewrite this as the quotient, you have x squared, or 1x squared, minus 16x plus 83, with your remainder of negative 220. And that is just a completely different way to do long division of polynomials. Okay, this linear, constant, linear, quadratic, that's not part of the problem. It's just helping you realize, okay, we start with our remainder, and then we just work our way up as far as we need to go. So that's synthetic division. Welcome to the world of synthetic division. Let's try another one. So we are dividing we're dividing x cubed minus 57x plus 56 by x minus 7. So the first thing that you want to do is reverse the sign of the divisor. So instead of x minus 7, you're going to use 7. And then you want to list the coefficients. Now this one's a tiny bit different. And can anybody guess why? Dom? Yes, you do. So we're going to have our coefficient of x cubed. We don't have x squared there. So what we want to do is we want to add in a 0. Because if we would rewrite this with placeholders, we'd have 0x squared minus 57x plus 56. And then negative 57 and positive 56. Second step, bring your first coefficient straight down. Multiply that coefficient by the divisor. 1 times 7 is 7. Add 0 plus 7. 7 times 7, 49. Add down the column, negative 57 plus 49 is going to be negative 8. Negative 8 times 7, negative 56. When we get 0 here, when we add, that tells us what's 0. Rachel? Very good. So our remainder is 0. And then you work your way backwards. Constant, linear, quadratic. So we are going to have a quotient of x squared plus 7x minus 8, no remainder. Do you guys want to do another practice problem with synthetic division, or are you good? You're good. You guys good? Yes? No? Yeah, you're good? All right. Then we will just stop there.